Today we are going to talk about multimodal feature engineering, the power of combined data types like combining various model, image or text, image or videos, image or audio. So let's go through it. So let's say AI with all the scenes, right? Think about how you process the world. You don't just see the friend to smile, same time you hear their voice, notice their tones, and maybe read their text message same time. Now think about teaching AI to do those similar kind of things. That's the multimodal AI system that combine text, image, audio, and behavior same time. Make smarter, more human like decision. So the perfect example for this one is TikTok, right? It watches what is in video. It listen in the music or voice over. It's read the caption and hashtags, right? And it study how you interact with them. Like so all these signal fuse into the one decision. What's the next video you will love to see, right? So in this article, I'm going to talk about how to build multimodals and some of the code and how you can build for real use case, right? So multimodal means multiple source of truth. Instead of just text or just image, you combine richer pictures, right? So here, for example, input are four types: text input, image input, and audio inputs, and 10 behavior inputs, then all the processing unit for each one, and then it forward to fusion model, and then combine output analyze what's the next, right? So example for multimodal: text and image, Instagram post with the caption, and audio and video, podcast with the transcripts and clips, tabular and sensor data, e-commerce sales, click stream logs, right? So common source, you can see text, caption, comment, and transcript, image, object detection, motion analyze, audio, like speech, tone, music, genres, and environmental sound, user behavior, click, watch time, scroll. Example: TikTok detect a cat in a video, right? And like this, right? And here the playing the background sounds and read cute kitten playing piano and see you rewatch twice behavior. So based on that, they can do new video to suggest you. Why the feature engineering use multimodal? So why they use input, you can see input is text data, then transfer into image 2040 dimension, then image, and then transform audio 120 decibels, and then feature tunings and the aligned output. So feature engineering is like playing before concerts. You might have amazing musician but your model, but if the instrument your feature is not tuned, the music will be off, right? Multimodal AI, each instrument speaks different language, different scale. Text embedding my 760 dimension, image factor is 248. Overlap surplus caption might be repeat in image, but audio could be reveal the emotion text image. Data imbalance, sometime like tone of text, very little audio. Data fusion puzzle, do you combine early raw feature or late model outputs? Somewhere it's between. So I think that's how you need to do, right? Flip sides, if we combine early, high cost, overlap, if you not do right, the flip side done wrong, so high cost, our fitting missing inside. If you do right, accuracy boost like 10 to 20% tasks like sentiment analyze and recommendation system. So now always start with domain experts. They will tell you which modality actually matters, serving your time and compute costs. So basic so now we are going to the third point, the basic of feature engineering, which we are going to talk about, like what is basic: input, clean, transform, explore, and select, and the output. So this is the things you need to go. So the fuse how to fuse multimodal works. So there is two type: early fusion model and the late fusion model. So early fusion, text, image, we conquered them, single model and early fusion. Now late, what we do some like text input, late model A, model voting A, voting B, the average voting, and late fusion. And here is the example. Using text, we use commonly BERT is embedding techniques. I have code in GitHub. I will share below. So basically, what it do, it import required library, then initialize BERT tokenizer. So if you see BERT tokenizer, we use BERT base uncast. So BERT base uncast, smaller 12 layer BERT model. Don't distinguish case, right? BERT base uncased, BERT base uncased, right? Tokenizer and model. And then we created function convert input tags into BERT embedding vector. Input is input tags in print, output is numpy 768 dimension embedding vector. So tokenizer is input and preprod BERT return return PyTorch tensor. So if you see here PyTorch tensor, return tensor tags, and truncation equal to true. Truncation true, handle the text longer than BERT, max is 570 token. Padding is true, ensure the all uniform length, padding shorter sequence, right? And so this is code I have provided in Git. Both image, we use ResNet 50 average pooling, and then we fuse from we combining feature using early fusion, concatenation, late fusion, model averaging. So early fusion we just do this, late fusioning we do some pooling. So real world example, TikTok recommendation, video, audio tags, use behavior fuse max engagement. Medical diagnosis, MRI scan, doctor notes the faster, more than accurate result. Self-driving car, LiDAR camera, GPS data sets, navigation. Fusion style, early fusion, fast but sensitive noisy input. Late fast, more robust, work even if modality missing. Hybrid fusion, attention mechanism, dynamically weight modality. Advanced advanced multimodal tips, multimodal tips, advanced multimodal topic, right? So which we talk about cross modeling learning like clip, align image text embedding, imbalance data, use weighted loss or our sampling, right? Can use like that. Scalability tool like Dask and Hug datasets which can be faster. Dask is previously my lecture I have gone through. Bias and ethics, use audit with Fairlearn, especially to when the modality involves the personal data. Challenge and best practices you need to do. Compute cost, GPU, TPU often is needed. Data privacy when mixing sensitive source. Model interoperability. Best practice to start with a small dataset, cross-validate often, cross-validate and track feature important vision featuring takeaway. So multimodal AI, outperforms single modality system by 50 to 40% metrics like accuracy and engagement. Fusion strategy matters. Early versus late hybrid depend on your data. Real world in TikTok feeds life-saving medical diagnosis. Try here my full code and read. This is the paper. So if you really like claps, if you not clap, it's okay. Please subscribe. YouTube video. I also have a YouTube video. Thank you for watching, liking, and following.